Hello friends. Yes. Now today we are going to see the next two cardinal points, that is the nodal points and nodal planes. So already we have studied the two focal points and focal planes we have studied. Similarly, we have studied the principal points and principal planes. Now, in this lecture, we are going to study about the nodal points and nodal planes. So first of all, revise all of you, that is about the focal points and principal points. So revise means you must, that is the revert your mind. What are the properties of focal points? What are the properties of principal points? Again, we are going to see the next one, that is the nodal points and nodal planes. To see the properties of the nodal planes and nodal points, again we are going to consider the thick lens. So as that is considered in the last lecture, we are going to consider the thick lens. So this is thick lens. Or there may be one lens here, another lens here, they are separated by certain distance. So this will also form a thick lens, or this is we have considered the thick lens. Now, this is the center of the lens. What is the first point we are going to draw? You are going to draw a line passing through the center of the lens, will not deviate in any direction. It goes straight. It is named as optic axis, or also known as principal axis. Okay. Now, to consider the nodal points. First of all, revise there are two focal points. So you know the properties of focal point 1. This is focal point 1. This is focal point 2. Two principal points. So this is principal point P2, this is principal point P1, and two principal planes P2H2 and P1H1. So this is P1, this is I will call here H1, I will call here H2, and I will call here T2, T1, and here T2. So what I have drawn here, see once again. Consider the thick lens. This is the center of the lens. Consider the 2 points, focal points, that is F2 and F1 on either side of the lens. Similarly, we have drawn the 2 points, that is principal points, on either side of the center, and 2 planes which are perpendicular to this optic axis. This one plane, another this one plane. That is, this plane is named as H2, P2, T2. H1, P1, T1. These 2 planes are called as principal planes. Okay. Now, I will put one, that is the object here. One object, put it at here. So, I will name this object as AB. I will again draw one line or one ray starting from the tip of this, that is the object, and going not parallel as we are considered in principal axis, not parallel, but we are going to consider the some slanting and incident at particular. So I will once again I will try here. It will go obliquely and incident on first principal plane or second principal plane at certain height, we may say S1. At certain height S1. So this is I will call here it is h1, small h1. So small h1 is a height at which the oblique ray incident on this plane, principal plane. So this is h1 is a S1 P2. This is the height of this, that is the incident ray. So now, will it go in the same direction? No. What is the property of this principal plane? If some ray is incident on first principal plane or second principal plane, then its emergent ray will start from the second principal plane at the same height. So now you draw the parallel line, dotted line up to this one, then name it as S2, then it will pass in this direction. This is emergent ray. S2, and where I will call it as the D2. Okay. So S2 D2 is the emergent ray, which is exactly parallel to this axis. I think we need to draw some good diagram. My diagram is not so much good, so I will draw like this. So this D2. So S2 D2 is the emergent ray which is parallel to this axis or this incident ray. And if I extend this ray up to principal axis or optic axis, what will happen? See, if I will extend this ray at this up to this optic axis, then this ray will touch the optic axis at certain point. This point is named as N2. Similarly, the emergent ray also touches the optic axis at certain point. This name as N1. So N1 is first nodal point, whereas N2 is second nodal point. Is it? Now, if I draw a perpendicular line through this point N2 and also N1, then these two dotted planes serves as or known as nodal planes. Is it? Now, if we consider the angle, this is alpha angle, this is alpha angle, and this is beta angle, this is beta angle. If I put my eye at this point, then I will see the object. I will see the object of height what? Of height h1. Of height h1. So h1 is a height of object. Can you imagine? That is, it is not actually AB at this height, but it is incident at certain height h1, and therefore, if you see through this lens, putting eye at this point, then you can observe this object here. That means this object is that is observed here of height h1. So h1 is a height of object. Similarly, if this I will look from this, what we see? What we can observe that when you see, then this is image of this object. Image of this object. So this is, that means S2, H2 is a image, height of image. Height of image. Is it? So when you look from this, then you will observe object. When you look in this direction, then you will observe the image. So that means S2P1 is an image, S1P2 is an object. Okay. So now this object subtend one angle, that is alpha, whereas this S2, that is this our image, will also subtend an angle beta. So now I will write here. So alpha is an angle subtended by object. Is it? So this angle is due to object. So angle alpha is an angle subtended by object. Similarly, beta is the angle subtended by image. Angle subtended by image. Now, if that is the magnification is taken, so that means it is called as angular magnification. Angular magnification. It is given by, it is the ratio of angle subtended by image to the angle subtended by object. So image angle divided by object angle, that means beta divided by alpha, because beta is the angle subtended by image, whereas alpha is the angle subtended by object. So image divided by object is nothing but magnification. So now this is angle we have taken, and therefore it is known as angular magnification. So beta divided by alpha, what we will get? Because as these two rays are parallel, alpha must be equal to beta. So if alpha is equal to beta, then these two will get cancelled, you will get 1. So what are the properties of nodal points and nodal planes? For nodal points and nodal planes, the angular magnification must be 1 or unit. Okay, that is angular magnification for nodal points is 1. Whereas if I will take h1 divided by h2, this is called as lateral magnification. Lateral magnification. That means what is h1? h1 is a height with respect to principal plane. h2 is a height with respect to the second principal plane. So these are also same. This is h1, this is h2. These are also same. So that means h1 divided by h2 is also 1. That is lateral magnification. Lateral magnification. So this unit lateral magnification is for principal planes. So what are the properties of principal plane? Principal planes are the conjugate planes where you will get the unit lateral magnification. Whereas the n1 and n2 are the two nodal points having the angular magnification is unit. Okay, can you understand this? So what we have seen, that is the two nodal points and two nodal planes having the property angular magnification.